exabytes, right? Zettabytes, ettabytes, ottabytes, so on, right? Yes. So from TB onwards, we see like huge data, right? Or big data, right? So do you think like, okay, you should have seen KBs of data, MBs of data, or even GBs of data, right? But do you think like petabytes of data, is it getting generated in the current real world, right? 1 petabyte equal to, right, 1024 TBs. Already 1 TB is a large storage unit, right? Do you think like 1 petabyte, right? Yes, 1 petabyte equal to 1024 TBs. So already 1 TB is a large storage unit, right? 1 TB is a large storage unit. So here 1024 TBs forms a petabyte, right? It forms a petabyte. So do you think like petabytes of data or exabytes of data, is it getting generated in the current world? If so, examples of petabytes of data generation, petabytes of data generation. Talk about a banking sector,
Facebook.
like, yes. If you take example of any bank like SBI or HDFC, right? We see within the city, we see hundreds of branches. Within the entire state, we see thousands of branches, right? Within the entire country, lakhs of branches for SBI. Again, within each branch, we call say like millions of customers. Each customer making multiple transactions per hour, per day, per week, per month, per year. Each and every transaction need to be stored, right? So huge data. And forget about this, everyone aware about the social media like Facebook, right? Facebook, it has got users not only within the country, it has got millions and trillions of users throughout the world. What is the data generated by Facebook in a minute? How many posts and videos are getting circulated? What should be the storage capacity to store all that videos and posts, right? So not like you see like it's what is the data generated means not in MBs or GBs, like terabytes and petabytes of data. Not only like Facebook, right? Today we have got many applications. Today, if we talk like many applications are generating data in petabytes. They are generating data in petabytes, right? Yes. 1 minute, if I talk about 1 minute of transaction, right? 1 minute transaction, right? Yes. In a minute, how many FB post, Facebook post, right? Yes. What is the data generated by Facebook? In a minute, how many Twitter tweets? What is the data generated by Twitter in a minute? What is the data generated by Google, right? Google queries, right? What is the data generated by YouTube videos upload? YouTube videos upload, right? Yes. So huge data, right? What to store all the videos, everyone creating their own videos and uploading in the YouTube, right? What should be the storage capacity to store all the videos? And everyone, right, has got millions and trillions of users using email messages, right? Email messages. Each and every message need to be stored, right? What should be the storage capacity to store all these messages? Or bank transactions, just now I was talking about the bank transactions, or if it like telecom transactions, or like Flipkart or Amazon transaction, right? Like e-commerce transaction, everywhere we see like huge data, right? Yes, not in GBs or TBs, petabytes of data. All these applications storing petabytes of data, right? Yes. Okay. Currently we have got databases, right? Currently we have got databases like we see like databases like Oracle, MySQL, right? We have got databases like Oracle, MySQL, DB2, SQL Server, right? All these databases, right? They are used for OLTP, online transactional processing, for day-to-day operations, right? But if you see, we have got some specialized databases. We have got some specialized databases used for data warehouse purpose, right? Like we got Teradata. If you heard about like Teradata, Netija, Teradata, Netija, Vertica, right? Yes. These are used for OLAP, data warehouse purpose, right? DWH, data warehouse purpose, right? Online analytical processing, OLAP. Online analytical processing, right? Yes. Databases and specialized databases both are used for, right? Okay. Okay. Now, these databases or specialized databases, they can handle data up to some extent, like databases in GBs of data, specialized databases in TBs of data, right? But to handle petabytes of data, right? We doesn't see these databases cannot handle like petabytes of data, right? As a solution to all these storage level problems, right? Not only storage and also processing level, right? We have got a framework like Hadoop for storage and processing. Later, I'll come back to this. What are the Hadoop and Spark services? But before that, if we talk about this, how this data is getting generated, data generations, and if you see data sources and data types, right? If talk, if you take, for example, if you take this is your data available, this is your data, right? Available. This data got generated from the last 50 years. Assume that from 1973 to 2023, right? This is the data which got generated, right? If you compare this data, right? Yes, if you see from 2013 to 2023, last 10 years data comparison with previous 40 years, right? See, previous 40 years. Only like if you see 20% of the data has got generated from the last previous 40 years, and nearly 80% of the data what we see currently has been generated from the last 10 to 15 years, right? The reasons for huge data generation, especially from the last 10 to 15 years, right? Because of usage of technology, usage of smartphones, usage of internet, right? Because of which huge data is getting generated from the last 10 to 15 years. And also, what are the main sources from where this data is getting generated? Mainly three sources of data, right? Three source. If you go back to, especially from last 10 to 15 years, this data has been, but if you see in 1990s or in early 2000s, right? The data was very less. We have got floppy disk. We used to carry data in floppy disk, 1.44 MB, right? Later you got compact disk, DVDs, like USBs, right? So day by day, you see like data increasing, the storage systems also increasing. In the earlier stages of mobile phones, like just 128 MB storage, you need to have in 2001 or 2002 at the earlier stages of mobile phones. The internal storage was 128 MB or 256 MB, right? But now even 128 GB is a very small storage. So is data increasing, right? So the storage systems also need to be increased. From where this data is getting generated means mainly three sources, right? Three sources of data. You can say like a social data, machine data, and a transactional data, right? Three types: social data, machine data, and transactional data. See, what is social data? Data which got generated from social sites, right? Like Amazon, like Facebook, Twitter, all this, right? And machine data means the data which got generated by reading or scanning the barcodes, RFID chips. So whenever you go to any shopping mall, right, for the items you purchase, you will get huge data getting generated, right, by reading or scanning the barcodes. Such data we call like machine data. And transactional data, like day-to-day operations, like bank transactions, telecom transactions, right? And What are the main types? Like three types, right? They are going to occupy three types of data. Three types of data, like structured, unstructured, and semi-structured, right? Structured data, semi-structured, unstructured, right? Structured data, semi-structured data, and unstructured data. Data which is organized in the form of rows and columns in a structured format, like DB tables, like Excel files, DB tables, database tables, right? Everything we call like structured. Semi-structured means they are not fully structured, they are not fully unstructured, right? Like XML files, JSON files, right? Yes. Unstructured, like short messages, articles, images, videos, all this comes as unstructured. The biggest challenge is like storing and processing this unstructured data. Today, if we see most of the data which is generated occupying this unstructured format, right? We need to have proper storage and processing systems to handle this unstructured and semi-structured kind of data, right? If we talk about databases, they can handle only structured data. They can process the structured data, right? So Hadoop is a kind of technology which can store and process this huge data, right? Yes. So as a solution to all the storage and processing level problems, we have got a framework called Hadoop. We have got a framework called Hadoop. Hadoop is meant for two things. So, okay. So Hadoop is, we have got a framework called Hadoop. Hadoop is meant for two things. Hadoop provides two services: storage and processing. Performs two things: storage and processing. Okay. Storage plus processing, right? Yes. So if you talk about any technology, right, they perform either storage or processing. If you talk about C or C++ or Java, .NET, right, all these, they are meant for processing. They are meant for processing, right? Yes. And if you talk about Oracle, MySQL, DB2, all this meant for storage. They are meant for either storage or processing, but Hadoop performs both storage and processing. But for storage, does Hadoop use any database internally? No. Hadoop is going with a kind of file system called as Hadoop distributed file system. And for processing, we are going with an execution model called as MapReduce. And currently we are using Spark, right? Yes. So for storage, we are using this. For processing, we are using this, right? Both combinedly can store and process. And you may get doubt, right? When Hadoop is able to perform storage and processing, what is the use of the current processing and storage technologies, right? So do you think that they will be away from the market when Hadoop in the market where it can perform storage and processing? No. You need to know where this Hadoop and Spark is used for batch processing, for batch application, right? Means millions and trillions of records go for Hadoop or Spark. For one record or two records, we no need to go for this Hadoop or Spark, right? And go with databases. For online processing, for day-to-day operation, go with the databases for one transaction or two transactions. For millions and trillions of records, right? Go for Hadoop, right? Yes. Now coming to this, right? Yes, understood, right? What is big data, Hadoop, right? So if I take big data, huge data generation. If I take big data as a problem, huge data generation, then I can say like Hadoop as the solution for it, right? Or if you take like big data as a talk like big data as a concept, Hadoop as the solution for it. Right. So now you may ask a query why databases like Oracle is not used for storing Hadoop's data. Drawbacks with the current databases, right? Yeah, drawbacks with the current databases. So first thing, right? Most of the databases, right? Most of the databases, less storage, very less storage. They can handle in GBs or in TBs, right? GBs or TBs. Mainly, most of the databases, no parallel processing in most of the databases, right? And if volume increases, right? If volume increases, saying like speed decreases, right? Yes, speed decreases. If volume increases, speed decreases. For example, to justify this, select total amount, sum of amount, right? Total amount from sales one. Sales one is the table, right? It's consisting of 10 records. Assume it has got only 10 records. And see one more query, right? Select sum of amount, right? Sum of amount from sales to, from sales to, it has got like 1 lakh records. Total amount from sales one, 10 records. Total amount from sales to 1 lakh records, right? Select select sum of amount, total amount of, yes, 1 crore records. 10 records, 1 lakh records, 1 crore records. 10 records, 1 lakh records, and 1 crore records. So which query is going to execute faster among these three, right? Yes, everyone. Either 10 records or 1 lakh or 1 crore. Which record, which table, like this or this or this? Which one is going to execute faster? So the first query, right, executes faster because total amount of 10 records as compared with 1 lakh or 1 crore, right? So query to query, as volume increasing, speed decreases, right? And if you talk complexity increases, if complexity increases, right, speed decreases, complexity increases, speed decreases. For example, select sum of amount from sales one. Assume this, if complex from sales one, right? Yes. You got some 1 lakh reports. Assume that you got 1 lakh reports. Next series, select average amount. Select average amount from sales one, right? Yes. Select sum of amount from sales one, 1 lakh records. Average amount from sales one, 1 crore records. So sorry, 1 lakh only. Assume sales one, same table, right? Select the standard deviation of amount. Standard deviation of amount, right? Standard deviation of amount from sales one. So all this, right, has got like 1 crore records. Sorry, 1 lakh records. Same sales one only, right? 1 lakh records. Which query executes faster among these three? Sum of amount from sales one, average amount from sales one, standard deviation of amount from sales one, right? First query again, right? Yes, because average amount is a two-step process. First sum to be calculated, next average to be calculated. Standard deviation is a lot of internal processing required. So again, the first query executes faster as compared with the other two, right? So here query to query, right? Query to query as well as this query to query, as complexity increases, speed decreases, right? Yes. And the major drawback with the databases, right? Databases can handle only structured data. Databases can handle only structured data. They can handle only structured data, cannot handle unstructured or semi-structured kind of data. For example, if you want to take reviews for a particular movie, right? Yes. So the table name is reviews. User 2, user 3, 100 users, right? 100 users. Uh, Review, right? Yes. Movie is good. First person saying movie is good. Second person saying movie is not good. Okay, for example, think that they are giving reviews in the form of ones and zeros. First person saying one, second person saying zero, 1 0. In this way, the reviews are given in the form of ones and zeros. One means good, zero indicates bad. Can you write an SQL query to count the number of ones and zeros? Means how many saying it's good and bad, right? We can write an SQL query for this, right? Count aggregation. Select review wise count from which table? Reviews table. Group by review. Review wise count from reviews. Group by review. What is the output, right? Yes. Zeros and ones, right? 1 and 0. What is the count? 90 people saying the movie good, 10 people saying the movie bad, right? Assume. This kind of structured data, okay. But if the reviews won't be given in the zeros and ones, right? They give the reviews in their own text format. First person saying movie is good, second person saying movie is not good. So in this way, they are giving in their own text format. They are giving the review in their own text format, right? Giving the review in their own text format, right? So here 90 people saying movie is good and 10 people saying the movie is bad, right? Now, can you write an SQL query, right, for this? If they are writing in the text format, how many people saying good, how many people saying it's not good, right? We cannot write a query even based on keyword count. If you try to see, right, if you want to count based on keyword, still it gives wrong computation, because even not good has got good within it, right? So the major drawback with databases can handle only structured data. But if we talk about this Hadoop advantages, right? Hadoop advantages. First thing, unlimited data storage. Unlimited data storage. Unlimited data storage. And secondly, very high speed processing. Very high speed processing. And can handle all varieties of data. Can handle all varieties. Unlimited data storage, very high speed processing, can handle all varieties of data, right? Okay. Open source, no licensing required, right? Open source. Unlimited data storage, very high speed processing, can handle all varieties of data, open source, no licensing required. Okay, unlimited data storage, right? Unlimited data storage, very high speed processing, right? So if you see examples, Yahoo has conducted a test, right? Yahoo has conducted a test to check the speed of various databases. It has taken a table, Yahoo has taken a table, right, of 100 TB, has taken a table of 100 TB, right, consisting of 1024 columns. Task, right? Task. Yeah, task, right? Sorting based on 16 columns. Sorting based on 16 columns, right? Yes. What is the time taken by various databases? Time taken by various databases. First one, right? Oracle has taken nearly 3.5 days to process this, right? MySQL, right? MySQL, it has taken nearly 6 days to process it. 6 days, right? And if you talk like specialized databases like Teradata used for data warehouse purpose can handle TBs of data just taken 4.5 hours, right? Yes. Another specialized databases like Netija, right? Right. It has just taken 3 hours to process this. But finally, Hadoop, right, has just taken 3.4 minutes, 3.4 minutes, and latest version of Hadoop has taken just 1.2 minutes, right? If you talk about Spark, it will take seconds, right? If Hadoop's Spark speed is more faster than Hadoop. So this is what the Hadoop speed, right, compared with other things where they have taken days and hours. Hadoop has taken just minutes of time. That is Hadoop is proven in the market, processing point of view, right? And even in the storage point of view also, Hadoop is proven, right? So you may, okay, processing point of view, right, very high speed processing. Today if we talk like most of the projects like ETL kinds of projects, they're migrating towards Hadoop and Spark environment, right? Yes. You may ask like why databases like Oracle, why I got see this query, right? Why databases like Oracle, databases like Oracle cannot support unlimited storage, cannot support unlimited storage, right? Yes. Why databases like Oracle cannot support unlimited storage? Why only Hadoop can perform? Why not this? Means Hadoop follows master and slave architecture. Single master and multiple slaves. Multiple slaves means a single master and multiple slave systems. But here there is a limitation for this. For this limitations, right? Databases and max limit, max limit on the number of slaves. Max limit on the number of slaves. Like if you talk like Oracle, right, it can have maximum 256 slave systems. 256 nodes are slaves, right? Slave systems. Beyond that it cannot, right, it cannot support data. Once these 256 slaves or systems gets filled, it cannot support data further. If we talk like MySQL, just it can support only 54 slaves. supports only 54 slaves. Yes. MySQL Express, right? MySQL Express. It can support nearly 256 slaves. And DB2, right? It supports nearly like 256 slaves. Oracle, MySQL Express, DB2, SQL Server, right? Yes, SQL Server, right? Like 256 slaves. Right. So they can support only up to 256. Beyond that, they cannot support, right? But we have got some specialized databases like Teradata, right? Teradata, it can support nearly 512 slaves, right? Systems for storing its data. And Netija, right? It can also support, right? 512 slaves. Vertica also can support nearly 512 slaves for storing its data. Okay, MySQL Express, DB2, SQL Server, Teradata, Netija, Vertica. But Teradata and Netija, now they are supporting nearly 1024 systems or slaves, right, to store its data. And Netija also supporting 1024, right, 1024 slaves for storing its data. Right, but still I cannot say like they are storing unlimited storage is possible. No, once they get filled they cannot support data further, but there is no limit, there is no limit on the number of slaves, that Hadoop can have, right? Yes, but there is no limit on the number of slaves that Hadoop can have. Unlimited number of slaves, right? So that, so Yahoo when first time implemented Hadoop, Yahoo when first time implemented Hadoop, went with 4,000 slaves. 4,000 slaves for storing its data. And currently it is going with, currently Yahoo using nearly 12,000 slaves or nodes, right, for storing its data. Facebook, right? Facebook when first time implemented Hadoop went with 8,000 slaves for storing its data. Currently it is going with, right? Currently it is going with 12,000 slaves for 42,000 slaves, right? 42,000 slaves for storing its data, right? Means there is no limit like the databases going with 256 or 512, but here they can go with the thousands. There is no limit on the number of slaves that Hadoop can have,
Yes.
right? Yes.
Vijay, sorry to interrupt. Can you please repeat what is the slaves and nodes are?
Yes, that I'll be discussing, right? So one second. See, Hadoop follows a single master, multiple slaves, master slave architecture. So Hadoop or Spark follows, right? Master slave, not client server architecture, master slave. Single master means these are multiple slaves. Slave nodes, we say. This is master node, these are slave nodes. Group of nodes, CPUs. Group of nodes are CPUs. They are connected in a network. One master node and all are nodes are slaves, nothing but systems, CPUs. One master node and multiple slave nodes. So in Hadoop, if there is a file, in Hadoop data is stored in the form of files. the data f1.txt. Think that your system or the slave 1 TB, 1 TB, 1 TB means each system storage is 1 TB, 1 TB, 1 TB. Slaves nothing but system nodes. Master node means it's a one system. Slaves and multiple systems, right? So each system capacity 1 TB. My file size is 2 TB. This 2 TB cannot fit into any of this file, right? Any of this system, it cannot be accommodated by any system, right? So in Hadoop, data is going to be split into smaller parts. It is going to be split into smaller parts and will be first part in one system, second one in another system, this in another system. Means distributed storage, you see. The data is going to get distributed across multiple systems and processed by multiple systems. Two advantages what we can see. Huge data file can be accommodated. Secondly, as it is distributed across multiple systems, they are processed parallelly. They are processed parallelly, right? Yes. Okay, they are processed parallelly. Okay, so we'll see very high speed, right? Because a single file distributed across multiple systems and is processed parallelly, very high speed. See, if work done by one system, work done by multiple systems, means work done by one person and work done by multiple persons. You can see that speed, right? Yes, that's what high speed. Okay. So these are the systems, means Hadoop horizontally unlimited number of slaves. Horizontally, you can keep on adding the systems or slaves, right? Slaves means systems. We can have any number of systems. There is no limit. But for databases, there is a limit. Yeah, how many systems can be? And Yahoo, Facebook went with 42,000 systems for storing its data. Initially, it was using 8,000. Currently, it is using this. Means there is no limit on the number of systems that Hadoop can have. Slaves, right, can have, but there is a limit in other databases. So storage point of view, it is proven, and processing point of view, it is proven in the market, right? Yes, understood, right? What is Hadoop, why Hadoop, right? And drawbacks with the databases, Hadoop advantages, right? And most of this today, if you see most of the applications generating huge data, so to be stored and to be processed, these big data tools are mostly preferred, right? Yes. One second. Now see these advantages, and as compared, some tests were conducted by Yahoo to check the speed of these databases, where Hadoop has taken minutes of time, where the other things they have taken like days and hours, it has taken minutes of time. And why databases like Oracle or this cannot support, means they have limit on the number of slaves. Fine. So if you see, uh, and if you talk about Spark, right? Spark, a very high speed processing technology, right? Used currently, it's has got great demand in the market. The tool has got great demand. About this Spark, right? The advantages, its features, all this I'll be demonstrating in the tomorrow session, right? But as what is the course structure, right? What is that course content we'll be discussing, right? I'll just show you what we'll be discussing as part of this course. Some Hadoop components and Spark, right? So like big data Hadoop introduction. Second, why Hadoop need of Hadoop data sources and HDFS, Hadoop distributed file system. We need to have the knowledge on this HDFS file system. It doesn't use databases as it got some drawbacks. Map reduce execution model, right? In Hadoop, and Scoop, SQL plus Hadoop. First two characters of this and last three characters of it forms Scoop, right? Import or export operations, how to bring data, how to pull the data from different databases, processing it, and after processed, the data need to be again taken to databases. Import and export operations, it's not for processing, it's just for importing data and exporting data, right? And filtering, transforming, all this. Yarn, yet another resource negotiator. So from Hadoop 2 version onwards, we got many architectural changes. yet another resource negotiator. And as a Hadoop and Spark developer, you need to have the idea about at least one NoSQL database, not only SQL for schema-less behavior, random access. NoSQL advantage is record to record different number of fields or columns can be maintained. In SQL, first record to last record, same number of columns need to be maintained, right? But in NoSQL, my first record with 3 fields, second record with 5 fields, third record with 10 fields, right? Record to record different number of fields can be maintained, right? And as part of our course, I'll be discussing the HBase, one NoSQL database, HBase and HBase data modeling and CRUD operations, and Hive and HBase integration. And next, the important Hadoop component like Hive, which is used for data warehouse. For we use a language called HQL here, loading data and making the data structured and creating tables, internal tables, external tables. We're working with unstructured XML, JSON data, working with URL, weblog data, unions, joins, UDF, UDAF, UDTFs, right? Non-partition, partition table, indexing, bucketing, partitioning, static partitioning, dynamic partitioning, right? And now coming to this PySpark, right? Spark with Python. So up to now, that is what Hadoop components that we'll be discussing, right? Now PySpark. PySpark real-time use cases, PySpark session, PySpark context, Spark context, parallelized repartitioning, broadcast variables, PySpark RTD computations, RTD persistence or persistence features options, PySpark core computation, and increasing the number of partitions, groupings, and aggregations, single grouping, single aggregation, multi groupings, multiple aggregations, group by key, reduce by key, various actions and transformations, right? Various one by one actions and transformations, count by key, count by value, sort by key. So one by one inbuilt transformations and actions, we no need to write huge codings. So various inner join, Cartesian, PySpark SQL data frames, right? Making the data structured using maps, RTDs, PySpark, RTD, PySpark show, row class, select, collect, with column renamed where, order by, group, join, union, one by one. All these APIs, right, with working examples. PySpark SQL functions, aggregate functions, window functions, date functions, JSON, right, read, right, and built-in functions, right, when, expression, lit, translate, overlay, two times time, percentage, rank, count, distinct, row number, rank, dense rank, type, lit, right, all this. And PySpark external sources, working with SQL statements, Hive integration, working with CSV, JSON, transformations and auctions on data frames, narrow and wide transformations, handling nulls, writing data back to external sources, deployment modes, local and cluster, PySpark applications, stages and tasks, driver and executor, deploying Spark applications to cluster, streaming integration with Kafka and PySpark, machine learning library, right? Yes. So all this in brief, right? In depth, we'll be discussing about entire data analytics with Hadoop and Spark, different APIs given, and with many working examples, right? Yes. Fine. Yeah. So I'll be briefing about the Spark features, advantages, how it is used in the real time, right? In the tomorrow session, right? So this is what the course content. So every session will be video recorded. You will be getting the recorded videos of it. And clear notes will be provided, right? Fine. So this is a weekend batch. Yes, give me a minute, give me a second, right? I'll just come back with your queries. uh, so on Saturday it will be like 2 to 2.5 hours. Sunday it will be 2 to 2.5 hours, right? 5 hours per week. So only on Saturday and Sundays it's a weekend batch. Yes. Fine. So it's totally of 12 weekends, right? 12 weekends. In depth, in brief, we'll be discussing, and all the softwares, everything I'll be provided, right, in through Google Drive, and videos also you'll be getting to Google Drive. Notes I'll be forwarding through mail, right? Fine. If you got any queries, you can go with your queries. And tomorrow also you can attend the session, right, at same time at 5:30 to see more on this. Mostly on Spark, I'll be briefing you, right, before I go with that basics of this big data, right? Yeah. Any queries you have got, you can go ahead with your queries, right? Yes.
Sir, can we have an end project? I mean, live project, something like that.
So at the last, I'll be showing you the flow, right, on this.
Okay.
So do we need to have Java and Python programming knowledge before continuing with this course?
So here, PySpark means you need to have Spark with Python implementation. You need to have the knowledge on Python, basic Python, right? Yes. So the course is of 12 weeks, right? And the fee structure is 12,000, right? For which constitutes both Hadoop and Spark, right? Previously, they were two separate courses. Now both we combined, we are giving for an offer, right? It's like 12,000 for both, like 12 weekends. It goes for 3 months, right? And the Hadoop and especially for Spark, total implementation goes in Python, right? And anyone wants to also, because first 1 month or 1 month I'll be discussing on Hadoop, right, where we won't touch any Python there. So by the time we can update with Python by the time when we start Spark, right? So people, and if you want Python also, I'll be also handling some Python batches, right? So those who wants Python also along with this, right? The package will be like 15K, right? Along with Python. You can join any of my Python batch, right? Which is going to be started. So, yes. So first 1 month we'll be having discussion on Hadoop, where we use we'll be discussing about these Hadoop components. By the time we start, we can just update with Python. If anyone not aware about Python, right? Yes. So, yeah. Any other queries, right? Yes.
Sir, since I've already joined Python just yesterday, so can it be clubbed with this course, my Python course?
Okay. If you're, yes, if anyone already done, right? So it was said, right? It's the 15K is that fee, right? So if anyone attending Python, if they want to get updated, right, 15K is the total package.
Okay, thank you.
And normal only for Hadoop and Spark. If you already had knowledge on Spark, it's 12K is the fee structure, right?
Okay, thank you.
Sir,
And I just wanted to understand, sir, the type of projects, like you will be doing a project, and will, like, at the end of this course or at the last 2 weeks or 3 weeks, what type of projects will be exposed to, or we will be doing on our own? Can we do on our own the projects once we complete the course?
Yes, totally. You will be getting command on this total Hadoop and Spark related APIs, right? When to use what, for what task, what to be performed, right? So will be during the course itself, right? We'll be designing many data flows, right? Spark, especially, it's a data flow language, right? So many data flows will be designing, right? Many with many working examples.
Okay, thank you.
sir, you have a separate classes for Python, or it is there in the class?
So no, separate timings will be there, and means this Tuesday at 7 a.m. in the morning, I'm starting a Python batch, right? Morning 7 a.m., right?
When when it's going to start?
On 31st of this month, after 3 days.
Okay.
At morning 7 a.m., right? At morning 7 a.m. there is a Python batch I'm going to start morning 7 a.m., right?
Okay.
And 31st of this month, and again 14th of this next after 2 weeks, right? There is one more batch in 7 p.m., right? I'm going to start.
Sir, is there no batch for weekend on weekend, because I'm working professional? Weekdays is not possible for me.
So most of the weekends I'll be dealing with Spark and Scala and Spark PySpark batches are there, and this data analytic batches. Mostly this I'll be dealing with. But people, okay, there are some people previously who have joined, right? If he doesn't have knowledge on Python, even if you attend the sessions, that's fine. Otherwise, following the videos, that's fine. If you're unable to attend, but there are no weekend batches. But whenever you have got any queries, people will be joining and you'll be asking the queries, right? Any 1 or 2 days, right? If unable to attend. Yes. No weekend batches for Python. No weekend batches for Python, but for this only we have got the weekend batches for this.
So this timings will not change, right? Or
No.
it
This
will
timing,
change.
this timing won't change. I have got other batches, right? Other timings. This will be
Okay.
fixed.
Yeah, because this is convenient, so that's why if it changes,
Yes.
then my schedule will change.
Yes.
Okay.
So are
Thank
you
you.
covering the installation steps also?
What is it?
Installation steps.
Yeah. How to install on Windows, how to install on Linux, and how to work on this Anaconda, Jupyter, Spider, PyCharm. All those I'll be discussing, right?
Okay. And I heard like the pig and yarn is out of scope, so nowhere there is.
Pig, we are not discussing pig, right?
Okay. And what about deployment like yarn so architecture? So that is also no more.
So
Airflow something kind of things you're using.
pig, yeah. Apache pig is we are not discussing that pig. Apache pig is not discussed. So
What,
other
okay. What
components.
about yarn? Yeah.
So yarn architecture will be discussing. Yeah, only the architectural part.
Okay. And
Okay.
deployment means like nowadays they are using Airflow. So instead of yarn, so nowhere they're using yarn architecture also.
So at the
So
last, I'll be providing that knowledge on that.
okay.
So
And if
HDF,
you
yes.
so you are covering the Airflow also, right? So the through the deployment option.
So this is what you can once again just to go through all this course content, right? It will be you will be getting this course content to your mail IDs. So all this in-depth knowledge on PySpark, all the APIs with many working examples, right? Yes.
Okay. And this PySpark, how it will differ from working in Databricks that's in cluster mode?
Yeah, that also how to work with the Databricks, that also I'll be discussing, right?
Okay. So and what about Delta live tables like you are covering?
What is it? No.
Delta live tables.
No, that is not covered here.
Okay. Fine. Thanks.
Okay, fine. Any other queries, right? Anyone?
Sir, how to pay the fees? I mean,
Yeah. Tomorrow, right? During the session, there will be. So you will be getting a mail, right? Whatever mail ID you have joined, you'll be getting a mail, right? They'll be giving the entire the payment process and procedure
okay.
right? Through. Okay. And also tomorrow during the class in the chart panel, they will be posting the payment options, everything, right? In the chart panel. Okay, fine. Okay, fine. So I'm stopping for now. So we'll continue tomorrow, same time at 5:30. You can follow the same link to see more on this, right? Tomorrow, mostly my discussion will be on Spark, PySpark, right? Introduction on this PySpark and the features, the advantages, all this, right? So I'm stopping for now. Thank you all for your time. Thank you.
Vijay?
Yes. Yeah.
Thank you.
Hello?
Yeah. Any query? Yes.
Can you hear me?
Yeah, I can hear you.
Already I opted for the Python and the data science and the tech of that. So already
Yeah.
that tech
You
will be on
you opted for
Python, data science, and the 7 batch.
okay.
Python.
Okay, there's yes. People who are already said, right, only for Hadoop and Spark it is like 12K, and if anyone already doing Python here in this Durga soft, and like if anybody wants to update with Python, right, the fee structure is 15K. If you already have done paid for this Python and if you're updating with the Python, right, so your total package will be 15K.
I'm about the timing of the classes.
Timing will be right every week on Saturday.
Already you
Five-
said that tech will be at the backend batch only.
This is a weekend batch, right? This is a weekend batch only.
No. Can you hear me?
Yes, I can hear you, right?
No, you said that full stack will be on weekend batch only. The 7 p.m. batch there. So this are
So all these are weekend batches. I'll be running from morning to evening, right? Many weekend batches on Scala, Spark with Scala and big data analytics, right? Many weekend batches. Yes. Okay,
I'll back to you there.
fine. Okay. So I'm stopping here. We'll continue tomorrow, same time at 5:30, right? Fine.
Okay, good morning, everyone.
Hi, sir.
Okay, so now we'll start, guys. So, good morning. So, my name is Samir, and I'll be your faculty for this. And when it comes to my experience, see, I have around 10 years of experience in IT, and since the past 3 years, I'm working on the cloud technologies. Okay, and that's it about my profile. And let's start now. Yeah, guys. Okay, so let's start. So here, so okay, everyone. So now let us start with the. Now, guys, let us see first of all, what is Azure data engineering? What is Azure data engineering? Okay. So, guys, what is Azure data engineering? Okay. So, whereas Azure is nothing but it is a name given for the product by the company called Microsoft. By a company called what? Microsoft. And then we have what is that? Data. Data is nothing but what? Information. Okay. That is nothing but what? Information. So whereas here we have what is that? Azure data. That is nothing but a Microsoft company providing, that is nothing but information, and Azure data engineering, that is application of engineering on the data. So whereas on this, or we can say within this Azure data engineering, we have the following services. So we can say that Azure data engineering is a group of multiple services. Okay, Azure data engineering is a there is nothing but it provides the group of multiple services provided by the Microsoft. Provided by the Microsoft. Whereas, guys, okay, whereas this Azure data engineering provides the following. What is that we have it? The first service, guys, this is here we'll have service. Here we don't say it as a product. Okay, or here we don't say it as the here we don't say it as the product, and here we don't say it as okay, that is a software. Okay, so here it is called as what? Service. The first service we have within this Azure data engineering is ADF, which stands for what? Yes, guys, which stands for what? Azure data engineering, which stands for what? Azure data engineering. Whereas apart from this ADF, we also have what is that? We also have the service in this, which is called as what? ADB, which stands for Azure Databricks. And apart from this Azure Databricks, we also have the service called, okay, that is Azure Synapse. Azure Synapse. Whereas, okay, I'll explain one after the other, don't worry. So Azure Synapse. And apart from this, we have many more services. Okay, some of the highlighted services I will tell you. Okay, Azure Synapse. Then we have what's that? Azure ML, which stands for that is machine learning. And then afterwards, even we have Azure AI, which stands for what? Azure AI. Azure, what is it? AI. So Azure AI is nothing but what? Artificial intelligence. Azure artificial intelligence. Okay. So likewise, you have many services. Everyone. Likewise, we have what is that? Many services, guys, provided under this Azure data engineering. Provided under this Azure data engineering. So now let us see what exactly this service does. So what is as ADF? So here we are here to see what is an ADF. So guys, let us start with this. So ADF, where as you know that ADF stands for what? Azure Data Engineering. What is it? Azure Data Engineering. Guys, you must and should interact with me. That's better. Okay. So what is it? Azure Data Engineering. So what is it? Data. Sorry. Under this Azure Data Engineering, we have what is it? ADF as a service. So ADF stands for what? Azure Data Factory. ADF stands for what? Azure Data Factory. So what is that? We have it? Azure Data Factory. So now what is that? Azure Data Factory? Yes, guys. Azure Data Factory is nothing but, okay, Azure Data Factory is nothing but it is a service. What is that? It is a service. It is a service provided by the, yes guys, it is a service provided by the Microsoft. It is a service provided by the Microsoft. It is a service provided by the Microsoft to perform the job of ETL or else ELT. That's it. So everyone, are you able to hear my voice? Please tell me, guys.
Yes.
Yes.
Okay, so now we have what is that? These are other things we have it. So now, guys, let us see. First of all, before we go ahead, let us see what exactly the extraction, transformation, and loading is. Then we will move further. Okay, okay, guys. First of all, when it comes to this ETL, the ETL stands for extraction. Extraction, guys. The ETL stands for what? Extraction. And then you have a transformation. And then you have what's that? Loading. Extraction, transformation, and loading. What is that? Extraction, transformation, and loading. Whereas in this extraction, transformation, and loading, this is nothing but the ETL is nothing but, guys, the ETL is used, or we can say the ETL is a process or a technique, we can say, which is used to perform the data summarization. To perform what is that? Data summarization. To perform the data summarization. ETL. Whereas this is a, we can say some olden technique we have it, that is called as what? ETL. Nowadays, even we have a technique introduced apart from this, that is called as what? ELT. Where ELT stands for what? Same. Extraction. Only the process has been changed here. Okay. What is it? The next one is called extraction. Then the next process comes here what? Loading, not the transformation. The next process comes here what? Loading. Extract and load first, then transform it later. So what is it? Transform? Transform it later. That means transformation, perform it later. Actually, what is transformation? Transformation is the actual process, guys. Transformation is the actual process where the data summarization is done. Where exactly the data summarization is done. Transformation is the actual process where the data summarization is done. So we have the same, both are same, ETL and ELT is same, but only the application part will change here. That's it. Okay, nothing else. So whereas these are the ETL. So what is ETL? Azure Data Factory is a service provided by Microsoft to perform the job of ETL, that is extraction, transformation, and loading. Whereas between the clouds and on-prem, between the clouds and on-prem, so we can say what is my on-prem? On-prem is nothing but on-premises. It stands for what? On-premises. Okay, guys, everyone, it stands for what? On-premises. It stands for what? On-premises. Yes, everyone, are you able to hear me?
Yes, sir.
On-premises. So whereas So before we go ahead, guys, I would just wanted to, I wanted to know first of all from you guys, what is the difference you have between the clouds and the on-premise, or if you do you know it or not?
Yes.
Yes, yeah. Need not hesitate, everyone. Just tell me what is the difference you have between clouds and on-premise. Any idea or not?
Yes, and on-premise, whatever the software is installed in your local system.
Yeah, that's fine. Really. And anyone else? Any other questions or any other opinions, please, guys? Okay, anyways, no problem. We will discuss it. So, guys, clouds and on-premises, these are the two different environments. So now let us try to understand these environments first. Okay, because if you understand this, then all the things you can understand. Okay, first of all, you have to make out the basic difference. What is the basic difference you have between the clouds and the on-premises? Clouds and what is it? On-premises. So clouds is nothing but, guys, basically, or what is an on-premises. So let us understand this with an example. Now, guys, everyone of us is using a mobile phone or not? Yes. Are you using the mobile phone or not? Please tell me,
Yes.
guys.
Yes.
All of you are using the mobile phones. Am I right? So now, in your mobile phone, how many type of memories you have it? Can you tell me? My question is that when you use a mobile phone, how many type of memories you will have it? Please tell me.
Internal memory and SD card.
Yes, internal memory and SD card. So that means, can you see here? Can we say that here if you have, okay, your total memory is what is it? Internal memory and SD card memory. That is scan disk card memory. So let us say some 10 GB, or we can say some 16 GB, guys, some 16 GB. Everyone can what is that? Yes, RAM, that is internal memory, and that is SD memory. That's it. So now let us say it here. 16 GB is provided with every mobile phone. Suppose let us assume some 15 GB or 16 GB is provided with a mobile phone. Now it means that we can store the data up to 16 GB. We can store the data up to 16 GB in your mobile phone. Am I right? That is the only thing it means. Am I right, everyone? Yes. It means that we can use up to, yes, guys, we can use up to 16 GB. We can store up to 16 GB of memory. We can store up to 16 GB of memory. Okay. 16 GB of memory. We can store up to 16 GB of memory in your mobile phone. Suppose I have to store more, 16 GB or more 20 GB memory has to be stored, or more some 32 GB has to be stored now. So at that time, what will I be doing? As this particular memory called my internal that is internal built-in memory in my mobile phone. That is nothing but the mobile phone built-in memory as it is not sufficient. I have to extend this. So for that, what I did, I bought an SD card. And now tell me, collaboratively, your mobile phone, can you see it? Collaboratively, your mobile phone memory and your SD card memory. Your mobile phone memory and SD card memory, collaboratively, how much it is? Mobile memory is 16 GB. And your SD card, scan disk card memory is what's it? 32 GB. Now, what is the total amount of memory you can store in your computer, that is in your mobile phone? Can you tell me, guys?
48.
42? Sure.
48.
Yes. So I think it is 48. 6 plus 2, 8, no? 10, 48. So totally your 48 GB you can store in your mobile phone. Now, other question. Now the another question arises. What is the other question is, now guys, suppose everyone, suppose I have to store some 500 GB of memory more now, or some 500 GB of data is there right now. In this situation, what will you do?
by
Google
external
Drive.
hard disk.
That means you will not get again the hard disk. Yes, you will not get again the hard disk. See, I'm talking about mobile phone. I'm just talking about mobile phone. Just forget about everything. So in your mobile phone, can you, yes guys, can you basically in your mobile phone, can you that is can you get a memory card of 500 GB?
No.
No.
No, we don't get it. So what will you do? Maximum we can get 32 GB of memory card, I think so. Isn't it? So if such is the case, but I have to store in my mobile phone 500 GB. So what is the other alternative? You can
Google
suggest.
Drive.
Ama?
Google Drive.
Yes. The another is nothing but Google Drive. So I'm just going and storing the data in the Google Drive. Now suppose what happened Google Drive. So in the Google Drive, the default memory provided is 15 GB by the Google, and whenever you want 500 GB data to be stored on your Google Drive, we have to buy the drive. Am I right, everyone? We have
Yes.
to buy the drive. So for that, how much will I be doing? I have to buy this drive. So I'll pay something and I bought it, and now I can store up to 500 GB memory. Am I right, guys? 500 GB memory. So now the question is that one fine day you lost your mobile phone. One fine day you lost your mobile phone. So when you lose your mobile phone, tell me now, what about the SD card memory? You have 48 GB memory available with you, whereas out of which 16 GB is the inbuilt memory and 32 GB is the uh, SD card memory. So this 48 GB, what about this 48 GB and what about this 500 GB data? Totally, you have 548 GB of data available right now with you or in your mobile phone. Now, one fine day you lost it. Tell me now, can you recover? Can you recover? My question is that, can you recover, guys? Can you recover the 16 GB of memory?
No, we cannot.
No.
Can you recover this 32 GB of memory?
No.
No.
Can you recover this 500 GB of memory?
Yes.
In fact, that means here, what you're doing, whenever you store the data in a Google Drive, if you lose your mobile phone, simply we buy a new handset and we log in your handset. We log in your handset just by using, we log in the handset by just using our email IDs. That is a previous email ID using which this Google account is created. And we enter the password. Once we enter the password, what happens? Synchronize option will be there. Automatically, whatever the data you have stored in the Google Drive, that means 500 GB of data which you have stored it can be retrieved back in a new handset with the help of the Google Drive. So now, when you store the data in a Google Drive, the saving responsibility, the data safety, whose responsibility? Your data safety. Your data safety is the responsibility of what? Google. That means the security of your data is the responsibility of what? Google. So you need not worry about it. Am I right? Yes, guys. Am I right, everyone?
Yes.
So now, and the second one is what? You can retrieve it whenever you want. Yes, whenever you want, you can retrieve it without any problem, irrespective of the location. What about the 48 GB you have it in your internal mobile phone? That is in the previous mobile phone, which you lost it. Can you recover it back? No. So whereas this is a very good example, guys. This is a very good example of what is that? This is the very good example. That means 48 GB which you already stored it in your previous mobile phone which you lost it. This is called as what is that? This is called as on premises. This is called as what? On-premises data. It is called as what, guys? On-premises data. And whatever the data, we store it in the Google Drive. Everyone, whatever the data, we store it in a Google Drive. This is called as what is that, guys? Tell me now. This kind of data or this type of storage is called as what?
Cloud.
Cloud storage. It is called as what? Cloud storage. cloud data. This is called as what? Cloud data. The data stored in the cloud. Now, guys, so most of us, many of us, almost all, every one of us nowadays, are we storing the data in a SD card? Are we storing the data anyway? Are we storing the data in the SD card, guys? Tell me now.
No, we are not
So
nowadays.
most of us, we are not storing it in the SD card. Simply what we are doing. That means we are simply what we are doing. We are, we have moved, we have moved from the physical data to cloud data. Am I right, everyone? Yeah.
Yes.
Am I correct or not?
Yes.
So everyone now, we are not storing the data in inbuilt memory. Directly we are storing the data in the Google Drive. Okay, or else we store the data in the iCloud when you use an iPhone. Am I right? Okay. So likewise, so slowly, we are habituated of clouds now. In the same way, guys, after this, the COVID, now, are we habituated of watching the movies by going to theaters? Yes.
No, mostly it has decreased.
No, mostly what we are doing, we are watching the movies, but we are
OTT.
watching in the watch.
OTT platform.
Very good. So we are watching in the OTT platforms. That means simply in your mobile phone, we download the OTT application, such as you have the Netflix is there, Amazon Prime is there. Simply we download it, and then once we download it, what we are doing? Once we download it, simply we are labeling it. That is simply we are taking the subscription, and that subscription will be what? Free or premium. If you want to watch a new movie, you have to pay and take the premium subscription and watch it. Am I right? So now slowly, what we are doing, our life is being moved from on premises to cloud only. In the same way here, guys, in the same way, going to the theater and watching the movie is called as what? On premises. Watching the movie on the OTT platform at your doorstep comfort is called as what? Cloud. So there it itself, we are moving it for entertainment purpose also. We have moved to the cloud. That is the cloud technology. In the same way, the whole globe is now migrating from cloud, that is from the on premises to the cloud environment. On premises to what is that? Cloud environment. On premises to what is that? Cloud environment. Okay. Basically, for your understanding, what I can tell you is, guys, cloud is nothing but basically, cloud is the Google Drive. You have it. And now, on premises is nothing but your mobile phone. That is physical, which you can see or which you can touch everything. Getting my point? Whereas, what about the Google? Where the Google stores the data? It's taking the data from you. It's providing you the storing. It provides you the 500 GB storage. But where does the Google stores the data? The Google stores the data. Guys, the Google stores the data. The Google stores the data in what is that? Data centers. They have some data centers. They have some what? Data centers. So now, guys, when it comes to the practical application, when it comes to the practical application in the IT industry, almost all the business entities are moving from on-premises to cloud now. Almost all the that is nothing but companies are moving from on-premises to what is it? Cloud now. Now, guys, Google Drive is provided by whom?
Google.
Obviously by the Google. Google Drive is provided by the Google. Am I right? So we can say that the service provider is Google or not?
Yes. Yes.
So now we can say that here the following are the cloud, or the following are the providers who are called as a service providers available in the market, who are offering the Google Drive service. That is nothing but who is offering the cloud service. And whereas who are them? The first one is, what is that? We have the Azure. Okay, what is that? Azure. So Azure is from what? Azure is from the Microsoft.
Right.
Azure is from what is that? Microsoft. Azure is from what is that?
Yes, sir.
Microsoft. Azure is from the Microsoft. Azure is the first cloud provider. And then apart from this, we have another one that is called as what? AWS, which stands for what? Yes, AWS stands for what? Amazon.
Amazon.
Yes, Amazon Web Service. Amazon Web Service. Then the third one, what is that? You have it?
GCP.
Yeah, we have the Google. Google is providing, or we can say GCP. That is nothing
Google
but
Cloud
Google
Platform.
Cloud Platform. Very good. So whereas the Google Cloud Platform is provided by what? Google. Whereas apart from this, we also have, yes, what is that? We have it SAP. SAP. That is SAP has come out with their own this thing. So we say it
HANA.
as what? Yes. Yes. Okay. And now, guys, apart from this, even we have what is that? Many more. That is Alibaba is there, China based. This Alibaba. Whereas, can you see here? Many more cloud providers. But whereas, as we have many in the market, we have many in the market. Now, guys, we have many mobile phones in the market available. But who is called as the market leader in mobile phones?
Happy.
iPhone.
Right. Apple is the market leader. Am I right? Who is the
Yes.
second market leader even today?
Samsung.
Very good. That's the thing. In the same way, why? Because of some good features, because of some good, the software they are using, whatever it may be. So in the same way here, we have many cloud providers available in the market, but the market leaders are these three only. These three only. Okay. Whereas Amazon was number one before. Now it has come down. Now it has come down to almost all the second position, and almost all you can say it has come down even to the third position. Why? The Amazon is more costly. The job which you can do it here requires 100 rupees. Suppose I'm giving you the same service is provided by the Azure in 15 rupees. You know what? So Azure is a very you can say economical service. They are providing it very cheaper service comparatively with Amazon. So hence what happens is market leader, and now the number one product available in the market in cloud technology is what's that? Azure. That is from the Microsoft. Getting my point? That is from the Microsoft. And whereas the Azure or Amazon or Google or SAP or whatever it may be, you have it, guys. All of them they are providing the cloud service. And these cloud services they are providing into three categories. What is that? The first one is called as what? IaaS. Whereas the second one they are providing in the form of what? PaaS. And the third one they are providing in the form of what? CIaaS. So what is IaaS, guys? IaaS stands for infrastructure.
Okay, service.
Yes, infrastructure. Infrastructure as a service. Infrastructure as a service. And now, guys, what do you mean by PaaS?
Platform as a service.
Yes, platform as a service. And then we have what is that? Third one. CIaaS. See, this stands for what?
Software as a service.
Yes, software. Yes, software as a service. That means, can you see here? They have provided their services in three different categories. In what is it? Three different categories. Suppose, for example, what is this infrastructure as a service? Let us try to understand this. What is an infrastructure as a service? When you talk about the infrastructure as a service, guys, suppose, okay, you have a very large amount of data to be processed, very massive amount of data. Does the Windows operating system supports for every data processing? So operating system, you know everyone. Yes, guys.
Yes.
So when you know that is operating system, can that Windows operating system supports for every amount of data or not? No. Whenever you have a very massive, large amount of data, Windows operating system is not supported most of the times. Am I right? So at that time, you need to change the operating system from Windows to, you can say mainframes. Suppose mainframes. Mainframes is from what? IBM. Mainframes is from what is that, guys? IBM. So whereas whenever you want to change the operating system, this operating system and all this is provided in the form of a service called what? Infrastructure as a service. What is that? Infrastructure as a service. Sorry, platform as a service. It is provided in the form of what? Platform as a service. Suppose, guys, suppose suppose you require to change an operating system. So right now I'm using the Windows operating system, and I am working into some banking industry. Banking industry is considered as what is that? An industry which provides a very massive amount of data. You can say the big data. So where the big data is not supported mostly onto the Windows operating system. So for that, we need to change the operating system from Windows to what is it? Mainframes or Unix or whatever we have it. Whereas you need not buy this again. Already you have a Windows operating system. You need not buy this again. Why? Simply you need to inform your cloud provider, that is called as Azure, to change your service, okay, of the operating system or of the platform from Windows to mainframes. So now licensing and everything will be taken care by Azure. You need not worry. Now, the next one, suppose you require to store the data. Same as I told you here in the example, I have some 48 GB of data now, and now I wanted to extend it to what is that? 500 TIB, that means terabyte, or PIB, that is petabyte. Okay, 500 petabyte. Okay, 500 petabyte data I want to store it. Okay, 500 petabyte data I want to store it. So now this much capacity you wanted to extend up to. So you will ask your, can you see here? You will ask your cloud provider called Azure to provide this much of storage onto the cloud. So it is the responsibility of the cloud provider to provide it for you. You need not worry. That's it. So now, guys, you need not worry about the license. You need not worry about the storage. Everything will be taken care by them. Simply what we need to do, we require a laptop and connectivity to the internet. That's it. We can start working on it. And then you have what is that? Software as a service. Software as a service, what it does? This is a service, guys, which is provided. This is a service which is provided in the form of what is it? Some you require some softwares. Suppose you require some softwares to go ahead or to work into your environment, such as, guys, such as, okay, now we have some applications, such as, for we can say some applications. So whenever we require an application, what we do in your mobile phone, whenever you require an application, what we do, guys? Tell me now. Huh? Guys, tell me, when you require any kind of a new
Go to the
application.
PlayStation and download it.
Very good. That is nothing but we go to the Play Store when you use the Android as an operating system, or whenever you are using the that is the Apple phone. Then we have what is that? That is nothing but Apple something is there now. What is it? You have it.
Play Store.
Apple, yes, Apple Store. We'll go to what is it? Apple Store and download. So whereas this we can say what is it? The set of all the applications we have it. So whenever you require some softwares or some applications to be installed on your PC, that comes under the software as a service. That comes under what is it, guys? Software as a service. That comes under what? Software as a service. So which is simply we need to inform our cloud provider to install this or to make it available for you. License everything with is the there's nothing but is the responsibility of Azure only. That is not our responsibility. Getting my point? Simply we need to pay the cost. Simply we need to do what, guys? Pay the cost. Pay the cost. Cost is mandatory. So you have to pay the cost for that. And this billing will be done on what is it? Monthly basis or hourly basis, weekly basis, daily basis, based on your comfort. Based on your comfort. Okay, so that means you pay more, you get more services. You pay less, you will get the basic services. That's it. That's the only concept. Like we have in OTT platforms, everyone. We have an OTT platform. What we do by default, some free web series are provided, some free movies are provided, some free television channels are provided. But if you want to see the premium one, the latest release, then we have to opt for a premium service by paying some cost. Am I right, everyone? Yes, guys, am I right or not?
Yes.
So this is
Yes,
the,
sir.
yeah, this is the concept why we moved from the, guys, why we moved from the, why we are moving it from the on premises or to what is that, cloud. Now, guys, this point is clear for me. But the next point here is what? Okay, cloud is clear, everything is clear. But one more thing is not clear. That is called as what? What is this Azure Data Factory? We have not discussed this. And as we know that Azure Data Factory is nothing but it is what is that? A service provided by Microsoft. It is
Yeah. So, good evening, all. So myself, I'm Vijay. I hold nearly 17 plus years of experience, which includes nearly 8 plus years of experience in Hadoop and Spark environment, right? So as part of today's demo, I'm going to cover the following topics. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, sir. Screen is visible, sir.
Fine, thank you. So what is big data? Why Hadoop and Spark? And what are the drawbacks we see with the current databases, right? Drawbacks. Drawbacks with current databases, right? Hadoop and Spark advantages. Hadoop and Spark advantages. Yes. Hadoop and Spark components. Hadoop and Spark job market. Fine. Yes. So in today's session, mostly I discuss about big data and Hadoop, right? In the tomorrow session, I'll be discussing mostly on Spark and advantages. Yes, its features. What is big data? What is big data, right? The name itself saying, right? Huge volumes of data. You see the current, how the data is stored currently, right? Data storage units like KBs of data, right? MBs of data, GBs of data, gigabytes, terabytes, petabytes, exabytes, right? Zettabytes, etabytes, ottabytes, so on, right? Yes. So from TB onwards, we see like huge data, right? Or big data, right? So do you think like, okay, you should have seen KBs of data, MBs of data, or even GBs of data, right? But do you think like petabytes of data, is it getting generated in the current real world, right? 1 petabyte equal to, right, 1024 TBs. Already 1 TB is a large storage unit, right? Do you think like 1 petabyte, right? Yes, 1 petabyte equal to 1024 TBs. So already 1 TB is a large storage unit, right? 1 TB is a large storage unit. So here 1024 TBs forms a petabyte, right? It forms a petabyte. So do you think like petabytes of data or exabytes of data, is it getting generated in the current world? If so, examples of petabytes of data generation, petabytes of data generation. Talk about a banking sector. Yes. If you take example of any bank like SBI or HDFC, right? We see within the city, we see hundreds of branches. Within the entire state, we see thousands of branches, right? Within the entire country, lakhs of branches for SBI. Again, within each branch, we call say like millions of customers. Each customer making multiple transactions per hour, per day, per week, per month, per year. Each and every transaction need to be stored, right? So huge data. And forget about this, everyone aware about the social media like Facebook, right? Facebook, it has got users not only within the country, it has got millions and trillions of users throughout the world. What is the data generated by Facebook in a minute? How many posts and videos are getting circulated? What should be the storage capacity to store all the videos and posts, right? So not like you see like it's what is the data generated means not in MBs or GBs, like terabytes and petabytes of data. Not only like Facebook, right? Today we have got many applications. Today if we talk like many applications are generating data in petabytes. They are generating data in petabytes, right? Yes. 1 minute, if I talk about 1 minute of transaction, right? 1 minute transaction, right? Yes. In a minute, how many FB post, Facebook post, right? Yes. What is the data generated by Facebook in a minute? How many Twitter tweets? What is the data generated by Twitter in a minute? What is the data generated by Google, right? Google queries, right? What is the data generated by YouTube videos upload? YouTube videos upload, right? Yes. So huge data, right? What to store all the videos, everyone creating their own videos and uploading in the YouTube, right? What should be the storage capacity to store all the videos? And everyone, right, has got millions and trillions of users using email messages, right? Email messages. Each and every message need to be stored, right? What should be the storage capacity to store all these messages? Or bank transactions. Just now I was talking about the bank transactions, or if it like telecom transactions, or like Flipkart or Amazon transaction, right? Like e-commerce transact. Everywhere we see like huge data, right? Yes. Not in GBs or TBs, petabytes of data. All these applications storing petabytes of data, right? Yes. Okay. Currently we have got databases, right? Currently we have got databases like we see like databases like Oracle, MySQL, right? We have got databases like Oracle, MySQL, DB2, SQL Server, right? All these databases, right? They are used for OLTP, online transactional processing, for day-to-day operations, right? But if you see, we have got some specialized databases. We have got some specialized databases used for data warehouse purpose, right? Like we got Teradata. If you heard about like Teradata and Netija, Vertica, right? Yes. These are used for OLAP, for data warehouse purpose, right? DWH, data warehouse purpose, right? Online analytical processing, OLAP, online analytical processing, right? Yes. Databases and specialized databases both are used for, right? Okay. Okay. Now these databases or specialized databases, they can handle data up to some extent, like databases in GBs of data, specialized databases in TBs of data, right? But to handle petabytes of data, right? We doesn't see these databases cannot handle like petabytes of data, right? as a solution to all these storage level problems, right? Not only storage and also processing level, right? We have got a framework like Hadoop for storage and processing. Later, I'll come back to this. What are the Hadoop and Spark services? But before that, if we talk about this, how this data is getting generated, data generations, and if you see data sources and data types, right? If talk, if you take, for example, if you take this is your data available, this is your data, right? Available. This data got generated from the last 50 years. Assume that from 1973 to 2023, right? This is the data which got generated, right? If you compare this data, right? Yes, if you see from 2013 to 2023, last 10 years data comparison with previous 40 years, right? See, previous 40 years. Only like if you see 20% of the data has got generated from the last previous 40 years, and nearly 80% of the data what we see currently has been generated from the last 10 to 15 years, right? The reasons for huge data generation, especially from the last 10 to 15 years, right? Because of usage of technology, usage of smartphones, usage of internet, right? Because of which huge data is getting generated from the last 10 to 15 years.